Hey everyone, and welcome to today's Explainer. We're going to dive right into a super fascinating source text that outlines, well, a pretty profound architectural shift happening in artificial intelligence right now. The paper basically argues that the tech industry is moving way beyond the general-purpose AI we're all used to using today. We're looking toward a highly specialized future. And it details how this could all be driven by a new framework called Codatta. Now, if you've been following the AI space at all, you know that researchers are hitting some pretty real ceilings with how smart these systems can actually get, using traditional training methods. I mean, the models are incredibly broad, sure, but they kind of lack deep vertical expertise. So the source material we're breaking down today explores a really specific blueprint for how developers might finally break through that ceiling by fundamentally changing how the models actually learn.
Which brings us to this core fundamental question explored in the research. How do AI models evolve? I mean, we know they get smarter over time, right? We see the updates roll out constantly. But what's the actual mechanism behind that evolution? It isn't magic, it's architecture. Hooking into this core mystery is absolutely crucial because the answer could literally change everything about how the next generation of technology is built. The source text points out that right now, our foundational models are incredibly impressive generalists. They know a little bit about almost everything. They can write a poem, write some Python code, or summarize a massive article for you. But when you need flawless expertise in a high-stakes environment, say diagnosing a super rare disease or auditing a complex financial system, a generalist model just hits a wall. It simply doesn't have the depth. So how on earth does an AI go from being a broad generalist to a deep specialist?
Well, let's get into Section 1, the quest for specialist AI. And that naturally leads us into Section 2, beyond basic labeling. To really understand how we reach that new frontier, the source text explains that we absolutely have to move away from older methods. For years, artificial intelligence was taught through basic labeling, and these are incredibly tedious, really elementary processes. Think about human beings sitting at computers for hours, drawing bounding boxes around cars in a video, or tagging thousands and thousands of pictures of cats, or simply labeling a sentence as having a positive or negative sentiment. Now, that taught AI how to recognize surface-level patterns, sure, but it didn't teach it how to truly comprehend the underlying logic. That old method, it's just no longer enough. The new necessity outlined in the research is structured knowledge. We aren't just pointing at things and naming them for the computer anymore. To create a specialist AI, developers are now required to provide deep, structured information. We have to teach the AI not just what something is, but why it is, how it connects to other complex concepts, and what the strict underlying rules of a specific domain actually are. For example, instead of just feeding an AI 1,000 medical records and telling it to find keywords, structured knowledge involves feeding the AI the actual clinical reasoning a human doctor used to arrive at a diagnosis based on those records. It's a total game changer.
Section 3. Enter collaborative intelligence. So, how do developers actually deliver this incredibly complex, structured knowledge to a machine? Well, the text introduces the concept of collaborative intelligence as the ultimate solution to the generalist problem. One person, or even one standard dataset, simply cannot provide the sheer depth of structured knowledge required to build a specialist AI across multiple fields. It's too big of a job. It requires a collaborative ecosystem, a structured framework where different entities work together to inject advanced intellect into foundational models. And this is exactly where Codatta comes in. The paper describes Codatta not as some simple software update, but as an entirely new structural framework based heavily on collaboration. It's an architecture explicitly designed to facilitate a massive, organized transfer of human expertise right into artificial systems. Because the main challenge with acquiring specialized data is that it's scattered inside the minds of experts all around the world. Codatta proposes a system that relies on specific distinct roles working in perfect harmony. This ensures the AI doesn't just ingest more raw data, but actually learns better, more accurate logic directly from human specialists.
Let's break down Section 4, the knowledge provider.
To really understand how Codatta works in practice, the text deconstructs the two key engines driving this whole architecture. The first one is the knowledge provider, which basically acts as the front line of this collaborative ecosystem. The exact definition from our source text states that a knowledge provider, or KP, is an entity that supplies advanced intelligence to improve foundational AI models by offering structured knowledge. I really want you to notice that phrase, advanced intelligence. The research heavily emphasizes that these providers aren't just supplying massive raw data dumps. No, they are supplying intelligence. A real-world example from the text might be a senior software engineer who doesn't just upload a giant block of code, but actually maps out the logic, the constraints, and the specific optimization choices behind that code.
The knowledge provider is that vital human element that pushes the AI beyond elementary learning and straight into the realm of complex comprehension.
Now, this structured knowledge consists of three very specific pillars: reasoning, evidence, and domain expertise. First off, providers don't just give an AI the final answer to a problem. They provide the reasoning, the actual step-by-step logical pathways required to arrive at that answer. Next, they provide the evidence. If the reasoning is the path, well, the evidence is the bedrock. This means backing up the logic with hard facts, like citing specific case law in legal contexts, or referencing peer-reviewed clinical trials in medical applications. And finally, they provide domain expertise. And honestly, this is perhaps the most difficult thing for an AI to learn through basic data scraping. Domain expertise is that nuanced, highly specialized understanding that literally only comes from years of deep practical experience in a specific field. It's the gut intuition a veteran engineer has about why a certain material might fail under stress, even if the basic math says it shouldn't. By injecting reasoning, evidence, and domain expertise, the knowledge provider completely fundamentally changes the caliber of information the AI is absorbing.
Moving on to Section 5, the knowledge verifier.
But, as the source rightly points out, if you just have people pumping highly complex information into a system, how do you ensure it is actually correct and totally unbiased? That introduces the absolutely necessary second half of the collaborative intelligence equation, the knowledge verifier, or KV. You see, a knowledge provider cannot exist in a vacuum. The knowledge verifier acts as the essential counterweight and partner. Think of it like this. If the provider is the gas pedal injecting new advanced intelligence into the system, the verifier acts as the steering wheel and the brakes. They secure the integrity of the entire collaborative ecosystem. The text explains that the KV audits the reasoning provided by the KP. They have incredibly strict protocols to cross-reference claims, test the logic pathways for fallacies, and ensure absolutely no hallucinations or errors are being introduced into the training data. They rigorously check the evidence and validate the domain expertise to ensure the foundational model is learning absolute truth rather than just, sophisticated, confident-sounding errors. This rigorous audit process is exactly what makes the resulting AI trustworthy.
Section 6, Evolution of Foundational Models. When you combine the deep, structured knowledge from the knowledge provider with the rigorous, intense auditing of the knowledge verifier, the research argues that you trigger a fundamental evolution in the AI itself. And this is exactly why the entire architectural shift from generalist to specialist matters so much. A generalist foundational model trained on basic data can write a very catchy email for you or give you a pretty decent recipe for dinner. But a specialist AI, built through this collaborative intelligence framework, operates on an entirely different level. The source material suggests these specialists will have the capability to synthesize really complex, conflicting medical research to assist in diagnostics, or to perfectly audit intricate legal contracts for subtle liabilities that a general model would literally miss entirely. The combination of the provider and the verifier fundamentally upgrades the AI's capability from being broad and shallow to becoming incredibly narrow, deep, and absolutely reliable.
And all of this culminates in the core thesis of our source material. By supplying advanced intelligence through reasoning, evidence, and domain expertise, and then rigorously verifying that data, this collaborative framework helps foundational AI models evolve from generalists to specialists. It represents a massive potential transformation in what artificial systems are fundamentally capable of achieving, solving that exact ceiling we discussed at the very beginning of this explainer.
Which leaves us with one final super thought-provoking question based on the research. What domain will specialist AI master next through collaborative intelligence? If this architecture scales the way the text outlines, the applications are practically boundless. Will it be quantum physics, genomic medicine, advanced aerospace engineering? The Codatta framework outlines a blueprint to get us there, suggesting that the future of artificial intelligence isn't just about throwing more computing power at a problem, but about the collaborative intelligence of human providers and verifiers deciding exactly what frontier to conquer next. Thank you so much for joining me for today's explainer. Keep learning, and I'll catch you next time.